Anybody? So the sum is -5. What is the product? The sum never changes. But what is the product in this case?
X.
The product is 6. 2 times 3 is 6. Very good. Since the product is positive, we expect either 2 positives or 2 negatives. But because the sum is negative, we know both numbers have to be negative. And yes, somebody said 2 and 3, but it's -2 and it's -3. At this point, we need to replace this term using these numbers. How do we do that? 2x squared minus 2x minus 3x plus 3. Do not forget the equal symbol and 0. What do we factor out from the first two terms? What do we factor out from the first two terms? Very good. What is left in parentheses? Good. I copy x minus 1, I copy the equal symbol and 0, and now I'm expecting a sign and a factor. Very good. Because -3 times this is this, and -3 times this is this. Now, what is the common factor that I have to pull out and finish up the factoring?
2x minus 3.
The common factor is x minus 1. I'm not saying it's incorrect. Some do that, which I agree with. But the common factor is x minus 1. And what is left over is 2x minus 3. But it doesn't matter. You're correct. You can rewrite it as 2x minus 3 times x minus 1. It's the same thing. But the common factor that we pull out is x minus 1, and then we are left with 2x minus 3. And from here we have x equals 1, and we have x equals 3/2. Good. Again, this was a cumbersome problem. Look at how many steps we had to go through. First, we had to remember that a binomial squared is a trinomial, because if you make a mistake from here, the whole thing collapses. So binomial squared is 3 terms, not 2 terms. And the formula that we discussed for a month already, the first term squared plus 2 from the formula times the first times the second plus the second term squared. Then we have to move everything to one side. Then we have to combine by terms. Then I realize that I can divide because it's an equation. Both sides by -2 to simplify it as much as I can. Then I realize that 1 is not the leading coefficient and this is not a special product. So I had to find two numbers whose product is 2 times 3 and whose sum is -5. Okay, I found those numbers. Then I had to replace -5x by these two. Then I had to use factoring by grouping. Then I had to factor this. Then I had to use the zero product principle to find the solutions. I got tired by simply just going through the steps, just naming them. So it's a lot of work on these, but this is the top difficulty level. There is nothing above it. Okay. Good, so let's continue. Okay, so let's work on this problem. I'll explain why I picked this problem. Can anyone give us the degree of the polynomial on the left-hand side? So it's 5x to the 4th minus 20x squared equals 0. Can anyone give us the degree of the polynomial? The degree of the polynomial. The degree of this binomial. Degree is?
Is 4?
Yes, indeed. The degree is 4. Therefore, we expect 4 solutions. Let's back up for a moment. The degree of this polynomial was 2. We got 2 solutions. Even if they are the same, we have to get 2 solutions. Because the degree of this polynomial is 4. This is the leading term. The leading coefficient is 5. We expect to get 4 solutions, even if they repeat themselves. Good. I will divide both sides by 5. I'm not ever allowed to divide an equation, both sides of an equation, by a variable. Never, ever, ever, ever. But by 5, I am allowed to. If this were an expression, I would have never been allowed to divide. I can't divide an expression. I can divide an equation because I'm dividing both sides. So I get x to the 4th minus 4x squared equals 0. This divided by 5, this divided by 5, this divided by 5. Now I will factor out the greatest common factor. Can anyone give us the greatest common factor of these two terms? The greatest common squared. Indeed. What is left in parentheses?
X squared minus 4.
Excellent. But I know that this is a binomial, and I know that there is a formula that factors this completely. How do I factor it? How do I factor x squared minus 4? There's a special product for this.
Can you please show us?
Sure. It's x squared minus 4, which is x plus 2, x minus 2. Difference of squares. Perfect square, perfect square. So it's x plus 2 and x minus 2. It's the first special product in the factoring strategy for binomials. So therefore, we have those 4 solutions. X equals 0, x equals 0. So we have 2 solutions, x equals 0. When x plus 2 is 0, I have the solution negative 2. When x minus 2 is 0, I have the solution 2. So I found 4 solutions because the degree of the polynomial I started with is 4. So the solutions are 0, negative 2, and 2. Any questions on this problem? Don't be shy. If there is a question, please always ask. Okay, so let's work on this problem. So here we have x to the 3rd plus 3x squared equals 49x plus 147. Okay. So, what will be the very first step we need to perform here, without which we cannot continue?
You have to set it equal to 0.
Absolutely. If I don't have it set it equal to 0, I cannot continue. Thank you very much. So x cubed plus 3x squared minus 49x minus 147. But these are 4 terms. What is the only option I have? What is the only option I have for 4 terms?
Grouping.
Excellent. Excellent. What will I factor out from the first 2?
X squared.
Very good. What is left in parentheses?
X plus 3.
Very good. I'm not kidding. This is, I think, the best method. Because if you don't write x plus 3 and the equal symbol and 0, you may get confused here. And if you don't get to this factor, you cannot continue. So please understand, you don't have to cover it up per se, but don't look. Copy and now look.
Negative 49.
Negative 49. So negative 49 times x is this. So let's make sure that this is correct. 3 times 9, 7, and we carry 2. 12 plus 2 is 14. Excellent. Now, what is the common factor that is common, and I have to pull it out?
X plus 3. X squared minus 49.
Very good. But I look at x squared minus 49, and I know it's the same special product, the difference of squares. I have to factor completely. Good. So, how do I factor x squared minus 49?
X plus 7. X minus 7.
Very good. And I forgot to ask you from the beginning, what is the degree of this polynomial?
Right?
Very good. We have to get 3 solutions. Real, imaginary, I don't care. All the same, I don't know, I don't care. I expect 3 solutions. And here they are. Negative 3, negative 7, and 7. How do I get these? X plus 3 equals 0, move 3 to the other side. X plus 7 equals 0, move 7 to the other side. X minus 7 equals 0, move negative 7 to the other side. And these are the 3 solutions. Do we feel a little bit better? Do we feel a little bit better about factoring and solving equations now? Okay, I'll ask you again in the next few minutes. I don't think you can say no, but you may. Okay, this is an equation. I can never divide by x. That's not ever allowed. But I can divide both sides by 7 to simplify the equation. So then I have x squared equals 7x. Yes, I have to have everything to one side. That's mandatory because I have to have 0. Otherwise, I can on one side. Otherwise, I cannot use the 0 product principle. But now I have to change this into a product because if I don't change it, I cannot use the 0 product principle. So, how do I change this into a product? What do I need to do? How do we change the left-hand side into a product? What do we need to do, please? The strategy tells us what to do step by step.
Take out x.
Indeed, that's the greatest common factor. Very good. What is left in parentheses? Notice that if you do not write everything on one line and you miss this equal symbol and 0, you're going to change this equation into an expression and you're not going to find solutions. So what is left in parentheses?
X minus 7.
Very good. So when the first factor is 0, I get x equals 0. When the second factor is 0, I get x equals 7. And these are the solutions, 0 and 7. Any questions on this problem? I hope you see the pattern. They're all the same. 0 on one side, a product on the other. Is this something we want to look at? Please look carefully, say yes or no.
Yes.
Perfect. I'm going to change r into x, it's easier. So x squared minus 3x plus 4 equals x. Good. What is the first step we need to perform? For sure, absolutely. I know I sound like a broken record, but this is only to help you understand the steps and repeat them and repeat them and repeat them.
Move x.
Exactly. Subtract x from both sides. So x squared minus 4x plus 4 equals 0. Yes. Now careful. I start the strategy. It's a trinomial. It's in descending order, no greatest common factor, no negative leading coefficient. I cannot skip the special product. Is it a special product? Why?
X plus 4, x minus 4.
Careful. This is a perfect square. This is a perfect square. That's why this is potentially a special product. Only because this is a perfect square and this is a perfect square. This is minus. Look at what I'm doing. I don't even look at the middle term. I'm only looking at the first and the last. They're both perfect squares with minus. So I expect to get x minus 2, everything's squared equals 0. But I don't know because I have to check the middle term. I have not checked the middle term. I haven't even looked at it. What is the middle term in this expansion? Anybody remembers how do we calculate the middle term here? I repeated the formula several times today. What is the middle term of this expansion?
Negative 4x.
Indeed. Why? Because the negative 2 times the first times the second is 4x. If this is the same with the middle term here, then this is correct. If this is not the same with the middle term here, then this is not the factor form of this trinomial. Now I'm looking. Oh, excellent. So, how many solutions do you expect? What is the degree and how many solutions do you expect to get? What is the degree of this polynomial?
3 is 2.
2. So we expect to get 2 solutions. So we condensed it to this form right now. X minus 2 squared equals 0, meaning x minus 2 times x minus 2. I do get 2 solutions, but they are both the same. So in Pearson, you don't have to write 2 comma 2. If they are the same, you just write 2. Because if I call Janelle's name, I still don't have 2 people in there. I only have 1 person called Janelle, right? So do not copy it twice because the system, I think it will, for me, I'm fine. If you write both, I'm super happy. But I think that Pearson only wants you to write 1 if they are not different. For me, if you do write on the test next week, if that happens and you write twice, I'll give you the full credit. I don't care what the system says. But to be on the safe side, just when you get to this exercise, if the system requires you to write 2 only once, then write it only once. Good. All right, this is the same with 3 solutions. I want to go back to look at the review, so that's why I'm... Okay, this is not even a quadratic equation, this is a linear equation. Okay, we did something like this. But stop me, it doesn't matter. We did something like this. It doesn't matter to me. If you say yes, or we want to do it, we'll do it. Okay, do we want to work on this one? Okay, just let's
I'm
get
okay with all of them.
good. We can do all of them because I would like to get to the review. because there are other types of problems I like to review. Okay, if we have time left, then we can go back and finish each and every one of them. I don't mind at all. Okay, now, what do you think we should do here? For sure, the first step, absolutely mandatory.